If you had a shop and you wanted to set up a webcam in that shop and you wanted to get an email anytime a new customer enters the shop, how can you do it? The answer is you can use Python. That's what we're going to do in these videos. We will build a program which starts the computer webcam and it waits for objects to enter the view. And if a new object enters the view, the program will send you an email, and in that email, the object that entered the view is attached as a picture, as an image, just as you can see. So that's basically the program we want to build. We want Python to start the computer webcam, and the webcam should be live all the time and it should wait for new objects or persons. So whenever a new object enters the view of the camera captures that object, draws a rectangle around the object, and it triggers an email. So an email will be sent to your email address in real time, and that email will contain attached the image which contains the object which was moving at that time. Right, so this is quite a fun project, but it's also very useful. This is where you learn the skill of threading in Python. This is very important. Unlike you learn threading with a real world example like this one, you will have a hard time to understand what threading really is. So please stay tuned and let's move on to the next videos. See you. Welcome to today's programming concept. In this video you'll learn what images are from a computer science perspective. Please don't skip this video because in the second half of the video we're also going to look at some Python code. So what are images from a computer science perspective? That's something that as a programmer you need to know, because whenever you process images you need an understanding of what they actually are. In fact, today and tomorrow we're going to process videos and images. So let's look at images from a theoretical perspective first. Let's consider a very small image which has only 12 pixels, so 4 horizontally and 3 vertically. As you know, each pixel has a color, right? So for example, we have this blue color here, white pixels, white, purple, etc. Now, the computer stores this image as numbers. So this is a matrix which symbolizes this image, and I'll explain you now what these numbers mean. So each set of numbers represents a pixel. For example, the very first set of numbers 255, 0 and 0 make up the first pixel of the image. The second set of numbers make up the second pixel of the image, the third one make up the third pixel, and so on. Let's look at the fourth pixel. Let's zoom in here. What are these numbers exactly? Well, 187 is the amount of blue, 41 is the amount of green, and 160 is the amount of red. The combination of these amounts of blue, green and red makes up the purple color. You can see this, you can look at a graphic design software. If you do this combination, you're going to end up with this purple color. Now let's go back to the blue color. So the first number is always the blue channel. So that's 255 for blue, and that's the maximum number. You can have the maximum amount of the color. So it ranges from 0 to 255. Now 25500 means that this pixel has 255 units of blue and 0 units of green and 0 units of red. That's why this is pure blue. It only has blue. And then if you look at white, white is always a combination of full blue, green and red. Then we have one more white pixel here, and then we have the purple. So this first matrix here represents the first row of pixels. And then we have the next pixel, this here, the next one, and so on. So if you look at the last pixel here, this would represent the last pixel, which is white. The one before that is this greenish color here. So 47 of blue, 255 of green, so it's very green. And we also have some red. So this is some sort of yellowish green. Now here is where the video gets more interesting. Let's jump into PyCharm. I've created a project here and I've uploaded an image.png file. You can find this attached in the lecture resources. So this image is the one I was showing to you just earlier. So we have this blue and purple and black and green. So this also has 4 pixels horizontally and 3 vertically. So it's a very, very small image. It's just 4 kilobytes. Now, in Python, you can write a script by using the OpenCV library, which you can install with pip install opencv-python. Or you can install it from the Python packages. So please make sure that you're using OpenCV Python Node CV2. So you install it like this, but the way to import it is this here. So OpenCV is a Python library that does image processing. It can capture video from the webcam, it can process images such as making them grayscale, blurring them, etc. So it works on the pixels of an image or the pixels of a video. A video is also made of images actually, and you'll understand that better in the next videos. So this OpenCV library has this imRead method, which stands for image read. So it gets an image as input. This image should be in the project directory here, so image.png, the one I just showed you. Then you can print out that image using print array. Let me comment this out first. Let's print the image and see what we've got. So that's the same numbers, the same matrices that I was just showing you earlier in the presentation, in this video. So as you can see, for example, that's 255 of blue, 0 for green and 0 for red. So that was the very first pixel, the blue one. And then we have all the other pixels one by one, just as I showed you earlier. So what is this array anyway? Well, you can print out its type, run again. You'll see that this is a NumPy array. And NumPy is also a Python library. It's a third-party library, but OpenCV installs it when you install OpenCV. So it's a dependency of OpenCV. NumPy has this array, which you just saw. So that is the main object of NumPy. So it looks like this. It's like a list of lists. So it's used to store numbers and numbers and numbers. So big amount of numbers, because images have many pixels. This image here has only 12 pixels, but normally a real photo or picture you'll have something like 1000 by 1000 pixels, which is 1 million pixels, right? So in such an image, 1000 by 1000, you have 1 million pixels and times 3 for each of the color channels. You'd have 3 million numbers, right? So 3 million of these numbers. And then when you have a video is made of images, so you usually have 30 images per second. So that's a lot of data, a lot of numbers. But NumPy is a very efficient library, so it doesn't slow things down. And so OpenCV is built on top of NumPy. And with OpenCV, you can display actually the images. And if I uncomment this other print function, if I run this, that shape property of the array, which we create in here, should display the dimensions of the array. So it's 3 by 4 by 3. What does it mean? 3 is the amount of pixels vertically. So we have these amounts of pixels vertically. We have 4 pixels horizontally. And then we have 3 channels, right? So blue, green, and red. So OpenCV works on this order, blue, green, red. There are other programs which may have RGB and not BGR, but OpenCV uses BGR. And just before we close the video, I want to also show you this other script, which is basically the opposite of the one I was just showing you. What this does is that we import NumPy here, right? We import OpenCV, and then we create a NumPy array manually. So A is the variable which will contain this array. You see, this array is a method. It opens in here and it closes in here, and inside it contains a list of lists. So that's basically that array that I was just showing you. Here, it's the same array, but we're doing the process from the other way around. So we get a NumPy array, we get numbers, and then we produce an image. So if I run the script, this script will get that array and it will execute the imWrite method. We give a name to the image that will be saved in the directory here, and then we provide the array that will be written in that image. So this array will be converted into a PNG image. So if I run this, it will create this image.png file, which is again 4 horizontally, 3 vertically. So that's how you read, that's how you create images. And let's move on with the next videos. See you. Hi, welcome back. In this video we will start coding our email webcam detection app. I demonstrated you the app in the previous video, so let's begin. Create a PyCharm project, and we will basically need 2 Python files here. Why we need 2? Let's call this emailing and main. Please don't name it email because that may clash with a Python library called email. So use another name. We need 2 Python files because think about the program we want to build. It has 2 parts. It has the webcam part and it has the emailing part. So the webcam is the front end part and the emailing part is the backend. Therefore, in main.py, I will write the script which starts the computer webcam. That script in main.py will also detect movement in the webcam and it will capture that as an image. Then this main.py script will tell the emailing script to send an email using that image as an attachment in the email. And that's all. So let's begin with the front end. The the first thing I want to show you how to do is how to start the webcam of your computer. So for this, obviously you need a webcam in your laptop or desktop computer. So you either use the integrated computer of your laptop or use another USB camera or something similar. There are also apps which connect your mobile camera to be used by your computer. So you'll have to do some research on the internet if that's the case, if you don't have a camera on your computer. Right, so considering you have a webcam, then what you want to do is import CV2. CV2 is actually called OpenCV, so you shouldn't be installing that using this button, but go to the terminal instead and make sure that venv is activated and do pip install opencv-python. So opencv-python. That will install OpenCV for you, and you import it with CV2. Then we want to start the video. To start a video from the webcam, using the webcam, you write a variable and you say video is equal to cv2.video capture. So this class. And inside the parentheses, you have to place a number, either 0 or 1 or 2. So if you have only one camera in your computer, which could be the case if you have a laptop, for example, you have the integrated camera, then you should place 0 to use that main camera. But if you want to use your secondary camera, you should use 1. So perhaps you have a USB camera attached to your laptop and you want to use that USB camera, please use 1 here. Otherwise, use 0 to use the main camera. You can try either way and see what works for you. And then write two variables, check and frame, equal to video. Video is this variable, dot read in parentheses, so that's a method. And then for now, let's print check and let's print the frame and see what these will be. Run. And if you notice it, what's happened is that my computer camera, my webcam lights turned on, so the camera started and then it turned off. And I got true as part of the check variable and this matrix as part of the frame variable. So this is a matrix, it's a NumPy matrix. So CV2 collaborates with a NumPy library. The NumPy library provides these matrices as its specialized object type. So we have lists, which come directly from Python, and we have matrices which come from NumPy. So basically these are list of lists. And this thing here, which happens to be zeros, I'll explain you why. This thing here is representing the frame, the image that the camera captured. So it's only one image actually. So the frame is the image and the image is represented as numbers. Why is it 0? Well, because my camera didn't have time to actually do something. So if you import time here and then you say after this video capture, after video read, because this simply sets up the camera and this actually reads the first frame of the video. Because a video, what is a video? A video is just a series of images. When you hear, for example, 30 frames per second, that means the video has 30 frames per second, and these video players, what they are doing is they are simply displaying these 30 images in 1 second, and you see it, you perceive that as a video. So time.sleep 1 second here, and then I'll get another check 2 frame 2, so that was check 1 frame 1, we sleep for 1 second, another sleep here, sleep for another second, and a third check 3 and frame 3 here. And then let's print out frame 3, for example. Execute. Now the camera should be staying on a bit longer. And so what I've got here is the third frame. Right? Now we have some numbers here. All these rows represent one single pixel in the image. And each of the values represent the blue, the amount of blue, the amount of green, and the amount of red. So the combination of these 3 basic colors will construct the color for that pixel. And then we have the other pixel again, BGR, so blue, green, red. The same for the other pixel, and so on. So that constructs an entire image, an entire matrix, whatever you like to call it. So this is quite long, but you see these dots means these will continue. There will be many pixels, but they are simply not displayed here in the command line because it's too many data, too many pixels. Right, so you are wondering, right, we have the frames as numbers, but how do we see the frames? Can you show the frames on the screen? Yeah, you can do that using the IMShow method, but IMShow should be used inside a while loop. So let's create a while true loop, and video capture should be outside of the while loop, but reading the frames should be inside the while loop. So previously we were applying the read method multiple times, but now since we are using a while loop, that means we don't need to manually add the read method multiple times. The while loop will execute read multiple times, and I'd like to remove this once from the variable names. So basically in each iteration we will have a frame. So that will happen very fast. And then you say cv2.imShow, you give a name to this, let's say my video, and then provide the frame variable. This contains those matrices, so the images. So you want to display the images every fraction of a second or so. Remove this frame 3 as well. It's a good idea that before you get the first frame, you use time.sleep for 1 second perhaps, because that will avoid these black frames. So you give the camera some time to load. Then you want to create a key variable which should be equal to cv2.wait key 1. So cv2.wait key 1 as argument, and then you say if key is equal to ort q. I'll explain you what this is. For now, please follow me here as I'm typing. Break, and then go outside of the while loop. So in this level of indentation, and you say video.release. So you point to that video variable and you release the video. Let's see now how this will work. So let's execute. Once you run the script, this should pop up a program. So check among your programs, you should see something with this icon, this Python rocket. So open that and you should see yourself there. Now the video is a bit slow, and that is because in the script, I place the time.sleep method in here. So that means every loop will be 1 second apart from each other. That means the frames are being shown with a lag of 1 second basically. So in other words, we are creating 1 frame per second here if you use that. And of course, if you print out the frame here somewhere inside the loop wherever you like print frame, that variable, you'll see that the numpy array, the matrix will be printed out every 1 second here. So to fix this, you want to place that time sleep outside the loop. So once you start the camera, you wait 1 second and then you capture the frames. So you wait 1 second for the camera to load. And then stop the script, run again, and look for that program again. So there it is. So now the video is smooth and we can go back to the script and I'll explain you what this does. So these lines, well, this creates a keyboard key object basically. And then you say that if the user presses the Q key, we will break the video. So let's try this. Go to the view, focus with your cursor, make sure the focus is in the app and not in another app on your computer, and press Q. That will stop the program. So it will release the video and yeah, the camera stops. And now if you want to process those frames, you should do stuff in here. You should code lots of things in here if you want to save them and so on. That is something we're going to do in the next videos. So for now, that was how to start the computer webcam. Thanks for following and I'll see you later. Hey, welcome back. In this video, we will continue working on our webcam program. So far what we have is this. So we display the video on screen. This is what the camera is capturing. And now if an object enters the camera, we should detect that object. And the way to detect that is here. So let me explain you the algorithm we will apply to detect movement. So first of all, we will store the first frame in a variable. Why do we need the first frame? Well, because the first frame is the static frame, right? There are no objects we want to detect in the first frame. And then the approach will be to compare the other frames to the first frame. So we compare the second frame to that, we compare the third frame to that, and so on. The way we will compare the other frames to the first frame is by doing the difference between those frames and the first frame. So in the first while loop iteration, we make the difference of the matrices, the matrix of the second frame with the matrix of the first frame. So if the second frame is the same as the first frame, that means there's no object, there's no change in the image, there's no movement. So we do the same difference between the third frame and the first frame. If there's no difference, that means there's no movement. So we carry on with the fourth frame. Now, if there is difference, we will end up with a matrix down here, this kind of matrix. So if you display that matrix, it will look something like black somewhere in here, and then in here we will see the difference, this person here. So that will be the difference between that frame here and this frame in here. So the first frame and the fourth frame. So that will be the difference. And then we will clear up that image. We'll apply some algorithms to smooth that area, and then we will draw some rectangles around that area here, and then we will find the rectangle in this frame here, the rectangle around the object. So then we get that rectangle and then we draw that rectangle in the original frame, in the original current frame, and we display the frame on the screen on the computer, right? So this image here will be displayed in here with the rectangle inside. So let's do this. Let's go back to PyCharm. Let's stop the script and continue coding. The very first thing we want to do here is we want to convert the frame, so all the frames, to grayscale frames, because that will reduce the amount of data in matrices. So these matrices are too complex. They have these three channels, blue, green, and red. That is unnecessary for making differences between pixels, so we will have only one grayscale channel. To do that, we say gray, so gray frame. To be more clear, gray frame will be a variable which will be equal to cv2.cvt color, so cvt in lowercase, color with c in uppercase. And then you provide the frame you want to convert to gray frame. Frame is this. And then you provide the color underscore bgr to gray. So this is the algorithm that will be applied to all the pixels. Sorry, this is CV2. So all the pixels of the frame, the original frame, will be applied this algorithm to convert those pixels to gray scale pixels. Another transformation we want to apply to make calculations more efficient is the Gaussian blur method. So let's say gray frame, Gauss for Gaussian, and that would be cv2.Gaussian blur with capital G and capital B. Now here you want to provide the gray frame. So the gray frame will be blurred a bit so that it doesn't have so much noise. We don't need all that precision. And in parentheses, you provide another argument. So we have the gray frame argument, and then we have this tuple. Like, you can provide a number. 22 is a good compromise here. So this will be basically the amount of blurriness you want to apply. Then you want to provide the standard deviation, and 0 is commonly used, so please provide 0 there. So we have three arguments, this, that, and that. Now, let's show this gray frame, Gauss frame, instead of showing the frame here. Gauss, so it's this variable, right, that we want to show. And let's try to execute. So there we go. So you can see that now the frame is grayed out and it's also blurred. So press Q to stop this. So that's how the gray frame Gaussian blur looks like in here. Right, so that was some pre-processing of the frames. Now we want to make the difference of the pre-processed first frame with the pre-processed second frame, third frame, and so on. So each frame will be compared to the very first frame. But how do we get the first frame? Because we cannot just do like frame minus frame or something like that, since in the first iteration frame will be equal to the first frame. But then in the next iteration it will be equal to the second frame, in the next iteration after that it will be equal to the third frame, and so on. So we need one variable which will hold tight the first frame and it will never let it go. So a technique to do that is to write a variable outside of the while loop, like first frame, is equal to none. So first it's none, and then the trick here is to say if first frame is none, first frame is equal to gray frame go. So why did I write this? Well, because let's say we start the program. The program assigns none to the first frame variable, and then the first iteration occurs. In the first iteration, the frame will be equal to the actual first frame. So it will be equal to a matrix, right? And then the program goes here and it says if first frame is none, and in the first iteration that is true, so first frame is none, because it got the none value in here. If that is the case, then we assign the gray frame go to the first frame variable. So now the first frame variable contains the gray frame go frame, which is the very first frame of the video. Then the loop goes to the second iteration. Again, the frame variable will get as a value the frame, the matrix of the second frame. We pre-process that frame with these, and then the program goes in here. Now, is first frame none this time? No, it's not. First frame now it's equal to the previous gray frame go. It's holding tight to that very first matrix, right? So that means first frame will continue to be equal to that very first frame. Even in the third iteration, frame is updated, but first frame is not none. So it will not be reassigned to the current Gaussian frame. It will hold to that very first frame. I hope this is clear. So that's the trick, to have the first frame in a variable and the current frame in another variable. So then we can do differences. We can say cv2.absolute_diff, sorry, it's with lowercase d, and we want to make the difference between the first frame as the first argument and the current frame, which is gray frame go. And we save this result in a delta frame. And if you want to see how this delta frame looks like, you want to get that imshow method, cut it from there, place it below delta frame. So delta is here, and now we want to display the delta here. So change that second argument to delta frame, delta frame. Yeah, this one. So this is what we've got. Now let's run the script, but I do suggest you that before you run the program, you disappear, you go away from the camera view so that your camera looks at a static background, like a wall or some furniture. And then once you run the program, then you want to go in front of your camera. So this is what I'll do. So I'll go away from my laptop, run the program, this is what we see. Now if I go in the frame, what we see is the delta frame. So basically these are the pixels where there's a difference, the different pixels showing the difference between the first frame and the current frame. So white means there's a lot of difference. So there's potentially new objects in these white pixels. Now this is good, but so currently we are at this stage, in this frame here. This is good, but as you can see, there's a lot of noise, lots of information here. We want to simplify this by having only black and white in the frame. So basically we will have only white pixels where there's an object and only black pixels where there's no object. So this is some type of classification. We will classify the pixels based on a threshold, because let me show you actually, if I stop the program and I print out the delta frame, so somewhere maybe here, print delta frame. So I want to show you how the pixel values look like now. So I'll go away from the camera again, execute the program, and I'm still outside of the camera view, and you'll see that the numbers are very small here. You see zeros and ones, perhaps some threes and some fours. What these numbers are is the black pixels. So basically the view currently is black pixels. But if I show now in front of the camera, we'll have more values which are higher. You see now we have 52, 69s. Those are values, pixel values, which are closer to the white color. So in other words, closer to the zeros means black pixels. Closer to 255 means whiter pixels. So pure white would be 255. Now we want to make use of those numbers in here. So after the delta, after showing the delta frame, let me remove that print delta, and here we want to apply cv2.threshold. So we want to classify the delta frame pixels, and the second argument of this is the threshold. So we want to classify as white pixels which have a value of 30 or higher. You can play around with this value, so I think 30 would be a good value. And these pixels, we want to assign them a value of 255. So in other words, if a pixel has a value of 30 or more than 30, we reassign a value of 255 to that pixel. So we categorize the values in zeros and 255s. Then the algorithm will be cv2.thresh binary. All these should be in capital letters, these algorithms. Now this should be saved in variable, let's say thresh frame is equal to that, and this will be a list actually, so you want to extract the second item of that list. So please apply that one as an index there, and then we want to get that imshow method from there, cut it, paste it in here, and here we want to say thresh frame this time. Again, we want to execute the script, so please go move away from the camera, run main, wait a few seconds. So I'm away from the camera now. This is the static view. Now I'll go inside the view. Right. So it's not ideal because I see lots of white areas. So in that case, you want to play around with this number. So stop the script and perhaps try 10. Go away from the camera. So that depends on how light there is in your environment, in your room. So let me try with 10. So this is worse. So what we need is a higher value actually. Let's try 45. Go away from the camera, run. And then move to the camera. So this is quite better actually. So I'll try one more time with 60. Run. So our goal here is to have only the object in white and the environment as less white as possible. Of course, you cannot make this ideal, but I think this is good results now. So let me quit this. Right, so we have the thresh frame. To remove the noise from this, we want to delete it using cv2.delete. So we apply the thresh frame here, none as the configuration array. So we could apply a configuration array here, but that would be an overkill here. So I'll just keep it simple. Iterations 2. The higher you go with the iteration number here, the more processing will be applied to this method. So let's store this in a dill frame variable and then show dill frame in here in the imShow method. Then move away from the camera, run the program, and then enter the view. So I can see that the results on my face, it's a bit better, so we don't have much black now. So we should try to remove all these areas here, the black area, which is classified as non-object. And finally, we are at this step. So in here, now we want to create contours around this image and then find the rectangle around those contours. To find the contours, we create a variable and another variable, two variables, and these are equal to cv2.find contours. So contours provide the last frame that we processed, dill frame, as the first argument, then the algorithm, which is cv2.retr_external. These algorithms are documented in the OpenCV library, and also another algorithm, cv2.chain approx simple. Right. So what this will do is it will detect the contours around those white areas. But there might be different white areas, right? Because, for example, when I enter the view in here, so there's the actual object, which is me, but you see on my side in here on the corner, there's another object, right? So we should try to draw contours around all the objects and calculate the areas of all the objects, and then we say that if an area is smaller than a number, then it's a fake positive, it's not a real object. This is what we're trying to do here. So this will be a list of the contours of all objects. So if there are two objects, there will be two contours. So we iterate over those contours for contour in contours. If cv2.contour area with a capital A of the contour is less than 10,000 is a good number, so 10,000 pixels, we continue. Continue means that if this is a small object, which means it is perhaps a fake object, it's not a real object, it's just the light differences in the static image, between the static image and the current frame. So if this is a fake object, then we continue, which means we run the loop again. Otherwise, we unindent here in the same indentation with if, and we say x, y, width and height are equal to cv2.bounding rectangle, rect contour. So we are still inside the for loop, right? So basically we are extracting the x and y of this corner here. You see my the red dot, that's the x and y, and we also extract the width and the height of this rectangle. That's what we do here. And then using those values, we say cv2.rectangle. This will draw a rectangle around the frame. Yes, this is the original frame. You see, that frame, the color frame. And then we want to display that frame down here, right? With cv2.show frame, give a name to that. Let's say video and frame. So at this point, frame will have that rectangle around itself. But in the rectangle methods, you want to add also the x and the y in a tuple. So that's one argument, this is another argument, and then you also want to give the x and y of the other corner, which is this corner here. You see the red dot, and this corner will be the x of this plus the width of that, and the y plus the height, basically. So we say x plus width, comma, y plus h. So the width and the h, the height. And lastly, in another tuple, we specify a tuple of 3 elements. So this will be the color of the rectangle. And this means it's green. So we give 255 to the green channel, 0 to the blue channel, and 0 to the red channel. So this will be a pure green color. And also another argument will be the width. So one argument here, 2, 3, 4, and 5 arguments for the rectangle methods. Yeah, let's run this. So that's the original frame. So if I enter the view now, you see these rectangles around me, and also it detects this object in here, in this side. So there are also fake objects that might be detected. However, it's important that these fake objects are detected when some new object enters the frame, because when I enter this view here, the shadow behind me is changing. So those shadows are also being detected as objects, right? But it still means that some object actually enter the frame, and that's our goal. We want to detect new objects which enter the frame. Anyway, you can still play around with this number. You can maybe make it smaller and see if you're able to detect any object or not. So let's try 5000 and rerun the script. So here we go. I think this is better. Now we see only one rectangle around me. Yeah, this is quite better. And yeah, that's how you detect movement. Now, this is still just a rectangle around the object that entered the frame. So we still have something else to do. We want to send an email to our email address when we detect a change in the frame. But that's something that we'll do in the next videos. For now, that's the code. Thanks for following, and I'll see you later. Hey, welcome back. Our program is working fine. It can detect objects and draw a rectangle around them. Now it's time to think about how we can connect this script with an email sending function. Well, for that, we're going to write a function in a separate file. So in this emailing.py file, for example. So let's define a send email function. And we're going to write the code later on. So for now, let's just print something like email was sent. Right, so this function now will have to be called from main.py. So when and where are we going to call the function? At what point in the script? So think again about this. The frame is static, no objects have entered the view, and then an object enters, right? So when this happens, we draw a rectangle around the object, but this should also be the point when we trigger that email sending function. So when we detect that there is movement, and that is, in my script, that would be in line 26, right here. Well, actually, it's not exactly line 26, but it is line 28. Because in here we are saying that if the contour is less than 5,000, the area, then we assume that there is no object, there's no real object in the camera. So in fact, if that doesn't occur, then this occurs. So at this point, we know that there was an object, so in line 28. But we can also do this like, we can assign a rectangle variable to cv2.rectangle. So we store the rectangle arrays, the rectangle numpy matrices in this variable, and then we say if rectangle send email should be imported. So from emailing import send email. So make sure that this is the name of your function, send email from emailing.py, send email from emailing. So we call that function in here if we notice a rectangle. Notice that if rectangle is inside the for loop, so one indentation level below the for loop. So let's try this. Run. So I always start with a static frame, so please don't show on camera when you are just running your program. And then introduce an object there. For example, I just introduced an object and we got an error. It says that the truth value of an array, so rectangle is an array, with more than one element is ambiguous. So you should use .any or .all. So that's what we do here. Rectangle.any, as we are being advised from the error messages. Run again. That's a static view. Let's introduce an object. So there we go. And you can see that in the terminal, we have this email was sent string being printed out multiple times. Right? So the email function, it's being executed as many times as there are rectangles being detected. So this would mean that the email function would be executed multiple times, and that means the email would be sent out multiple times, but that is not what we want because that's just too much. So we only want to send the email once. Now there might be different ways to approach this, but one way which we will use is to send the email when the object has exited the frame. So which means that now there's no object and then an object enters the frame. We don't send the email yet, but then when the object has exited the frame, then is when we send the email. So let's see how we can do that. Well, to do that, we can assign a value of 1 to this status variable. So this variable is 1 when there are rectangles. In other words, when there is an object in the view. Otherwise, status will be 0. Status is equal to 0. So when the loop starts, we always reset the status value. So basically we reassign 0 to status, but then if there are objects, the status variable is updated to 1, right? Then we also have, outside of the loop, we have a status list, which is equal to an empty list for now. So status list is equal to an empty list, and then we go in here where we are sending the email, and we go at this level, in the same level with the while loop, so indented under the while loop, but at the same level with the for loop, and we say status list.append. I know you are lost, but I'll explain this to you, what I'm doing here. So status list.append status. Why am I doing this? Well, let me print out status list so you see what's going on here. And I'll run the program. So make sure that these two are one indentation level. You see, inside the while loop. So run the script. And what we're getting is the status. If I introduce now this object and then I quit this, if you scroll to the end of this, you're going to see that the latest statuses are ones. So the latest values are ones. And in here, this is where the object entered the view, right? So we switched from a value of 0 to a value of 1. Let's do this again. Let's try again. So we have zeros, an object entered, it exit the frame, quit. Again, here is the switch from 0 to 1, the object entered the frame, but then in here, 1 to 0, this is where the object exited the frame. Now we can modify this status list by saying that status list is equal to status list -2 up to the end. So what this will do is basically, let's suppose we have this amount of items in a list. So status list is equal to this list, right? Zeros and ones. So what we're doing here is basically this. So let me copy that in here. And now status list is going to be updated by containing only the last two items of the list, because that's what we're interested about. We're only interested about the last two items if they are changing or not. Because if then status list 0, which is the first item, if that is equal to 1 and status list 1, so this item is equal to 0, that means the object has just exited the frame, right? Because this was 1, which means that there was an object currently in the frame, but then that changed to 0, right? Oh, sorry, this is equal to 0. So that changed to 0, and that means the object has just exited the frame. In that case, we might want to send out the email. So I'll cut that send email call from there and paste it in here. And let's run the script. Right, so now we get only these 0, 0, 0, 0. Let's introduce now an object. We have once. No email is being sent out just yet. Now when the object disappears, you saw that we got this printed out, this email sent. Yeah, email was sent. So this happened at the time when we switched from 1, 1 to 1, 0. At this point is when we sent out the email. And the email should also contain one of the images which will show the object inside the frame, the view, like a screenshot of the video with the object inside the frame. And that's something that we'll do in the next videos. So with this, we are done, and I'll see you in the next one. See you. Today you worked on processing frames of videos with OpenCV. Now your task for today's exercise is to create this web app. I'll show you some code to get you started though, because this contains something that we haven't covered yet. So in this video, I'll cover that aspect as well. But first, let's demonstrate the app, how it works. So if the user presses the start camera, then the user shows up. And so the idea is that your task is to create this app, but also to add this date, the day actually of the week, and the current time, which is still ticking. So sort of timed video camera. Right, so let me go to PyCharm, and I want to show you a simple version first. So this is not the solution is a bit more complex. This code here, what it does is this. Let me execute it. Streamlit run. So we're using Streamlit here. And this script is named simple.py. So run simple.py. This app is a bit simpler than the one I just showed you, because when the user starts the camera, the video shows up, but this time in here you see it's hello, it's not the date. So this is a bit simpler. So this app is constructed by this code. So we've got this motion detected title and start camera button. And so if the user presses that start button, that means the start button has a value. So if start, if the button has been pressed, then we prepare an image with Streamlit. So st.image with this list as input. So this will be like a placeholder where you inject the frames of the video. Then you start OpenCV. So previously in the course, we did cover a simple app with Streamlit. So Streamlit can also do this the other way without using OpenCV. But when you use OpenCV, you have more control over the frames. So you're working on a lower level code. So you have more possibilities what you can do with your code, as we do in this example where we will write some text in the image, and you can also write dates and times, which is your task for the day. So if the user presses the start button, then we construct the while loop, as you know. So we read the frame from this. You can call this camera or video, whatever you like. Then the frame is converted to color BGR to RGB. I wanted to show you this technique as well. You don't have to use it, but if you ever want to convert the channels from BGR, which is the standard of OpenCV, and you want to have the frames in RGB instead, then you can use this code. So every frame will be updated to the current frame, but with RGB. So that means then if you give some colors, for example, we give the color of text here, that means 20 is for R, so for red, and 100 is for green, and 200 would be the amount of blue. So this is optional, but just be aware that if you change that, you should supply the numbers in the correct order in RGB. So that is the code that writes text in frame. It has these arguments. I think these are self-explanatory. So that's the frame and that's the text you want to write. That's the coordinates of the image. They start from the upper left corner of the image. So if you're saying 50 here, that means we are 50 here. So from the left border to the text, and the other 50 is from the upper border up to the text where it begins. That's the idea here. Then we have the font and we have the font scale, how big you want the font to be. You can experiment with numbers. That's the color of the text, that's the thickness of the text, and that's the line type used to draw the text by OpenCV. And then inside this while loop we write the frame. So your task now is that instead of showing hello, you should show that dynamic day and the current time, just as I showed you in the first demonstration in this video. So thanks and see you later. Hi, in this video I'll show you the solution to the Streamlit app, which constructs this camera view, and we also have this Wednesday and the real time here. So let me show you the complete code. So that's the complete code, that's the first line, and that's the last line of the script. Let me explain you how I did it. I'll simply explain you the lines I added in addition to the lines that I showed you in the previous video where I gave you the task for this project. So these are the lines I added as new, and also line 3. So in line 3 I imported datetime, so the datetime class from the datetime library, because datetime, the class, allows me here in line 17, it allows me to get the current time. But this will be a datetime object, so it's a special object. It's not meant to be written as text. That's why in here I get that datetime object, which is stored in the now variable. So this variable here is also here. So I get that variable, that object, and I extract the string, a string from that object. So basically converting that. But in the string we only show the name of the day, so the day of the week, for example Wednesday, and I placed it at these coordinates. So 3080 means 30 from the left and 80 from the upper border. So the rest, I suppose, is self-explanatory since we covered this in the previous video. So I did this 2 times. I used the putText method 2 times. One for the day, Wednesday for example, and another to show the time in hour, minutes and seconds. So this one is in another color, and that was white, this is red. So that's it, basically. That's my implementation of this app. Thank you for following, and I'll see you later.